In this video, we are going to look at using equal values method in order to solve for a system of equations. So a system of equations means that usually I have not one line, but now I have two lines or more that I'm looking at, and I want to know where they intersect. For our purposes, we will only be looking at two lines, and I want to find out where they intersect. So this is one of the ways we can use to find that intersection point algebraically, and it's specifically for when I have a certain setup of those lines. So the first thing you should notice for equal values is both lines are set up as y equals mx plus b. That's the big thing to note. This is why we have multiple methods, because this isn't always going to be the case. So when this is the case, we are going to be setting them up so that they're equal to each other. So what that means is if I'm looking at these lines, I know that I can say y is always equal to y. That's that variable. The variable is always equal to itself, right? So this x value should technically be always equal to this x value here. So what I'm going to do is, because y is equal to 5x plus 4, and y is also equal to 8x plus 10, I can set these two equal to each other and solve for x. So what I end up with is 5x plus 4 equals 8x plus 10. So from there, I want to solve for x. The first thing I want to do is I'm going to move my 5x. Now, of course, you can do this in a different order. It doesn't really matter. So I'm going to move my 5x by subtracting on both sides. That leaves me with 4 is equal to 3x plus 10. So now I want to get 3x by itself. So that means I need to move 10. So I'm going to subtract 10 from both sides since it was being added on the right-hand side. And I'm left with negative 6 is equal to 3x. Now I need to get x by itself so I can solve for it. So 3 times x, to undo that operation, we have to divide both sides by 3. And I end up with x equals negative 2. So that's the first part of my coordinate that I'm going to need. So remember, I'm looking for a point. This is only part of it. So the next thing I'm going to do is I'm going to plug x equals negative 2 into one of these equations. It does not matter which one you choose. You will end up with the same answer no matter what, because this is the point of intersection. So if x is equal to negative 2, and I'm going to pick my first one, then I would get y equals 5 times negative 2 plus 4. From there, I end up with y equals negative 10 plus 4. Negative 10 plus 4 is equal to negative 6. So that means that my coordinate, my point of intersection, is going to be negative 2, comma, negative 6. So this is really our final answer, and that's what we want to make sure we have. So you're going to see a second example for this. If you need it, great. If you don't, that's okay. You can stop this video now. So another example of this. Again, I have y equals an equation and y equals an equation. Since y and y, we want them to be equal to each other, it means that this side of the equation, these are also going to be equal to each other. So that means that I have negative 5x minus 11 equals 4x plus 7. So similar to the problem above, I'm going to solve for x. The first thing I'm going to do is move, I think, the negative 5x to the other side. Again, you can do this in different order. It's totally okay. So plus 5x on both sides. And then I have negative 11 equals 9x plus 7. I'm going to subtract 7 from both sides then so I can get my variable by itself. And we're going to end up with negative 18 equals 9x. So from there, I need to get rid of this 9, which means I need to divide both sides by 9. And we end up with x equals negative 2. So again, what I'm going to do is I'm going to take x equals negative 2 and plug it into one of these equations. It does not matter which one you choose, you will get the same result. So I'm going to pick the bottom one this time. For x equals negative 2, then I end up with y equals 4 times negative 2 plus 7, and I'm going to solve from there. So we get y equals negative 8 plus 7, which means that y is equal to negative 1. So again, I can't just stop there. I need to find my point of intersection, right? My point of intersection. And that's going to be the coordinate negative 2, comma, negative 1. This is my final answer.